In a multi-phase batch process, there can sometimes arise a situation where material in one phase going over to the next phase is divided in separate streams, forming so-called sub-batches. And maybe later on in another downstream phase, all material is again joined in the same main product stream. In order to handle this kind of splitting of batches into sub-batches and later joining sub-batches to complete batches, SIMCA has a specific ID called a phase iteration ID. The objective of this how-to video is to show you how to work with this phase iteration ID and what consequences it has for instance, control charting objectives. The dataset that we are using to illustrate the use of the phase iteration ID is taken from our compilation of tutorial examples in our training material. We start a new batch project. The first step is to import data. In this case, it is from the example called phase_iter process. The Excel file has two worksheets, one for the training set and a separate one for the prediction set, and we choose to import the data for both the training set and prediction set at the same time. This means we get two tabs, one for each set. We start with the training set. Here, the primary identifier is more like a run order. We have a batch ID representing the 6 batches that we have in the training set. We have a phase ID identifying the 3 phases that occur within inside each batch. And then we have the phase iteration ID indicating whether in the first phase we are talking about iteration 1 or 2 or sub-batch 1 or 2. In addition to that, we also can define a unit ID. The phase iteration ID is called upon under the phase ID button, where you can then set what type of phase ID you're talking about. In this example, we also have to reassign something called a Q class. This is an end parameter. It is a so-called batch condition. It is a qualitative parameter and it is a Y variable. Furthermore, we have to set the date and time variable. We are choosing to parse time as hours, and it will be a Y variable. We switch to the prediction set and we run the same set of verification checks that we have a primary ID, a batch ID, a phase ID, a phase iteration ID, and a unit ID. Then we have this final end condition that is a batch condition. It is qualitative and it is a Y variable. Finally, we set the date and time column as date and time. We parse in hours and we set it as a Y variable. Now we have no issues reported in the issues pane. So we can finish the import, leave the import and give the project a name. And then we are moved over to SIMCA. In order to develop a new model, we click here. This will open up the workset wizard. We select a batch evolution model and click next. When we build the model, we only need the data from the training set. We will use all 11x variables. On the batches page, we can see that the training set has 7 batches and 3 phases. If we want to, we can expand and see which phases are active inside the different batches. We can also expand the phases to see if there is some sub-batch formation or some phase iterations. And in this dialog here we can see that it is inside phase 1 that we have a formation of a sub-batch. We then click next. This will bring us to the finish page, a final summary page where we can review and overview our settings and selections. And we will ask for one OPLS model for each class, where class in this case should be read or understood as phase. And we will auto-fit those models. When clicking on the Finish button, SIMCA issues a warning telling us that some variables are not active in certain phases, so we would want to exclude those constant variables from those phases. Now we are outside the workset wizard and we have calculated these three phase models. When clicking on the batch control chart in the scores mode, we will get three control charts because we have three phases. If we want to, we can zoom in on the individual phases by changing here. We can look at, for instance, the third phase, which is the ending thing, and we can see that all the 7 batches of the training set perform well and are within the upper and lower limits. Similarly holds true for the second phase. All 7 batches in the training set are well within limits. And finally, if we look at the first phase, we also see the same thing, but we have twice the amount of lines. We now have 14 lines. If we want to simplify even further, we can select only to plot one batch at a time. So now we can see the 2 sub-batches or phase iterations for the batch number 40 in the training set. If we want to highlight if the differences between the 2 sub-batches or the 2 phase iterations, we can choose to color by the phase iteration ID. And so the black color is the first iteration and the blue color is the second one. Sometimes the 2 phase iterations or the 2 sub-batches may change unit, and for that purpose we can also choose to color using the unit ID. Instead of selecting which batch to display using the properties pane in the right hand part of the screen, we can also use the arrow keys to quickly skim through the 7 batches in the training set. As you can see when you look at the individual batches, there is a little split between the 2 units, but in every case each unit trajectory is always, for all the 7 batches, inside the control limits of the phase model for the first phase. And this leads us to conclude that the 7 batches in the training set conform very well with one another, and that the model that we have developed, the 3 models that we have developed, are well founded. Additionally, beyond looking at the score control charts, we can of course move on and interpret these 3 OPLS phase models along the same lines as we interpret normal batches, meaning we look at loadings, we can look at totellings t-square and dmod x and all kinds of modeling statistics, but that is not the target with this recording. Here we're just showing you how to work with the phase iteration ID. And if you want to know the meaning of totelling t-square, dmod x, loadings and how to use them, we refer to other how-to videos on SIMCA dealing with those matters. What we want to do here is now to move on to the predict phase and try to see if these 3 models for the 7 batches in the training set can identify the batches in the prediction set as being good or bad. For that reason, we move over to the predict tab. We have to tell SIMCA which is the prediction set. And here we see a classification of those prediction set batches into the models. Under the Predict tab, we have access to similar tools and functions as we have on the Home tab. So we move on to the score plot, but for the predicted situation, predicted batch control charts. When we click on the scores button, we open up 3 batch control charts, working along the same mechanism as we did for the training set. We can start to watch, for instance, the control chart for phase 3. And because all the 6 trajectories of the 6 prediction set batches are well within the lower and upper limit, we conclude that all 6 test set batches conform very well with the model for the third phase. Similarly, when we look at the control chart for the second phase, we see that all 6 trajectories of the 6 batches in the prediction set conform very well with the model for phase 2. I'm just reminding you that instead of looking at all batches, you can select to look at individual batches if you want to simplify interpretation. And this of course holds true for all 3 phase models. Then moving on to the first phase, we will then see a split 2 lines because we have the 2 sub-batches or the 2 phase iterations. Again, if we want to know which is either unit 1 or unit 2 or the phase iterations, we can choose to color according to either of those 2 IDs. For this batch that we are currently looking at, batch number 23 in the prediction set, we can see that unit 2, the blue line, is very close to the golden trajectory, whereas the trajectory for the first unit shows a jump some 9 hours into the lifetime of this phase. In order to interpret what is causing this rapid shift for the first unit for this batch 23 in the first phase, we can use drill down technology. And when first marking that point in question and drilling down, we see that pH is the culprit variable. We can then double click on the pH bar and open up a variable control chart for the pH variable for batch number 23 and its first phase. And we can see that the problem seems to be that for the first unit, pH is constantly on the high side and touching upon the upper control limit. And after around 9.2 hours, there is this sudden and dramatic drop in pH from around 7.7 down to below 7. And this is causing the problem for this batch, this strange behavior. If you continue to analyze in more detail the 6 batches in the prediction set, you will see that all 6 batches conform very well with the models from the training set for phases 2 and 3. And there are 3 batches that are detected as deviating in the first phase. And the batch that we are looking at currently, batch 23, is one of those problematic batches in the test set that have problems in the first phase, and particularly the run in the first unit, that sub-batch. But eventually, for all the 3 batches that deviate in phase 1, it seems that phases 2 and 3, the processing there will harmonize all the 6 batches in the prediction set. So in the end, they conform very well with the model based on the 7 training set batches. This was what I wanted to show you. The target in this how-to video was the existence of the phase iteration ID and how to operate it and how to use it in different control charts. Thank you very much for watching this how-to video.